Hi there, welcome to this Unreal Engine tutorial. Today I'll just be sort of talking about AI perception, how to raise the AI perception point. We'll be going from your AI seeing this to your AI seeing this. I'd also like to apologize in advance for my voice. I'm a bit sick and not using the greatest of microphones, so if it sounds really nasally, I'm sorry. Alright, well, without further ado, let's get started. I'm using Unreal Engine 4.21, so yeah, we're going to launch that, and we're going to create a project together. So we're going to base this off of the glorious third-person template. So once you're in, you're just going to select Games, Third Person, Next, and you need this to be C++. All the other stuff you can sort of keep however you want it, right? But you need this to be C++ because this stuff is not accessible in blueprints. I'm going to call my project tutorial, just so that it's very easy to switch that out with your project name, because your character may be called your project name character or whatever, and this way it's just very easy to follow. So I'll create the project and I'll see you in the C++ files. Alright, here we are inside the project. This is our, completely standard default third-person template project. Before we get into the C++, I just want to make a quick pawn for testing, right? We'll do this in blueprints. So I'm just going to, I like being organized, so I'm just going to create a folder called AI. And inside, I'm going to create a new blueprint class. We're going to make this a character, just so that we have character movement. And if you're making actual AI, you'll probably want it to be a character just for character movement. I'm just going to call this testing underscore AI. And opening it up, very simple. I'm just going to set the mesh over here to the SK mannequin. We're going to drag that down 90 units. That should be 90. And rotate it 90 degrees. We're going to compile. On our mesh, I'm just going to use third-person NMBP, and we're also going to add AI perception. So AI perception is quite important. Obviously, it's what what your AI will be using to see other actors. And over here in AI perception, we're going to add a sense configuration. We're going to select this AI sight configuration. And on here, all of this stuff really doesn't matter. The one thing that we want to change is to add detect neutrals, since we're not going to be setting up AI teams in this tutorial. With that done, we can compile, close that, and just drag the AI out. Now if you play, and you walk up to the guy, and you press the apostrophe key on your keyboard, you're going to get this sort of view, and if you press 4, you'll see exactly what we're going to be working on today. He sees you at this little point here, and we want to raise that because in a situation like this, where you're standing behind cover, in a first-person shooter or whatever, or even just like a low wall, right? He already can't see me here, and I can quite clearly see him. So we want to raise this to be sort of at the head of our protagonist or our playable character. So with that set, and with that set up, you can just hit escape, Control-Shift-S to save everything, and I'm going to close the editor. This should have opened up in the background. This is the C++ Visual Studio window if you do have Visual Studio installed. I'm just going to close that because I closed the editor, so it's going to open again. So in here there are 3 classes we're going to want, and we're going to start with 2 of them. So under tutorial, you'll see I have tutorial character CPP and tutorial character.h. So the C++ class with all of our implementations, and our header class with all of our functions and our variables. I'm going to start in the header class, and we're going to start by including, right? So in our hashtag includes, we're just going to go include perception / AI site target interface.h. With that included, here to our class A tutorial character, or A whatever you name your project character, or if it's a custom character, A whatever you call your custom character. Right, we're going to append after public A character, we're just going to put a comma, and we're going to go public. And then we're going to go public IAI site target interface. If it doesn't autofill, well, I have Visual Assist, so it autofills for me. If not, you can just type it out. Now that you've appended public IAI site target interface, we can go over into our public. This should be auto-created. If it isn't, you can just sort of go there, type public, and hit. You need the double dot at the end. But yeah, this needs to be in public, and what we're going to do is we're going to create our function. Right, so we're going to go virtual bool can be seen from. And now we need to sort of input all the variables that we're going to be using in the implementation of this function. So one of them is going to be, alright, Visual Studio is not responding now because it's Visual Studio. Alright, we're back. Right, so one of these is going to be const f vector. You want an and sign after that. Observer location. After that, we're going to have another vector, f vector, again, another and sign after that. Out scene location. I'm going to move my mouse so it doesn't do that. After that, we want an int32, again, followed by an and this is going to be number of LOS checks performed. Then we want a float, again, and sign out site strength. And then we just want to have a null actor at the end of it, so just go const sorry, not AA actor, but A actor star ignore actor equals null in all caps. Visual Studio is being laggy again. Equals null. And then we'll follow that up by a const and done. So this is our function, but before we head into our C++ file to implement this, I'm a person who tends to like building modular systems that you can adjust through blueprints. And so I want this to be fully adjustable through blueprints about the location of this detection point. So we're going to create fname down here, detection socket bone name. And now to make that editable through blueprints, some of you will already know this, some of you won't, just new property, edit defaults only, category equals variables. With that done, those 3 lines of code there, we're ready to switch over to our C++ class. Now, since I have Visual Assist, I can just go down here and create an implementation of can be seen from. For those of you who do not have this option, you're free to just literally write this out in your C++ class anywhere. Within this, we're going to start our function. So first of all, we're just going to go static const fname name underscore AI line of sight. I'll move my mouse so you can see that, is equal to fname, and then we're going to want 2 sets of brackets. Within the first one, we're going to go text, and then within the second one, we're just going to write test pawn line of sight. Under that, we also need to define a hit result for use later with line traces. I also forgot to close that out. So just put a semicolon at the end of that, as you would with C++. So we also want to define a hit result, so I'm just going to go f hit result, and we're going to semicolon that off. Now we need to actually figure out the vector of the socket that we're using for this detection point. So I'm just going to go f vector, call it socket location, is equal to get mesh. Please don't crash Visual Studio, I swear to God. Get mesh, then we're going to want the arrow and just go get socket location. And then in here, we're going to plug in the name that we created earlier, detection socket bone name, and put a semicolon at the end of that. Right, now we want to actually check whether we're hitting this, whether we can actually see, or whether the AI can actually see this point. And for that, we're going to use, we're going to write a little bit of a function. So const bool, not const bool b hit socket, right? So it's a boolean, and we're going to check if we've hit the socket, and that's going to equal get world line trace load line trace single by object type single by object type. I clearly cannot type today. So first we're going to input the hit result. It autofills that for me. Then we're going to use observer location, which is something that we've passed through from our header class. Then we're going to use socket location. And now we need to define our collision parameters, right? And these will be consistent across both of the functions that we write. So we're going to go f collision object query params. Open that bracket, ECC underscore 2 bit field. Then we're going to open bracket at the end of that. And then within that open bracket, we're just going to type ECC underscore world static. Then we're going to put a little line, and we're going to go again ECC 2 bit field. And then within that, we're going to go ECC underscore world dynamic instead of world static this time. And then we're going to bracket that off. And then after that, we're going to just type a comma and go f collision query params. And then after that, a little bit of a bracket, name underscore AI line of sight, true, and then r ignore actor, right? And semicolon at the end of that, and we need 2 brackets there. Now that we've got that, we're just going to go number of LOS checks performed plus plus. We're going to add 1 to that. That's a line of sight checks, so we're just checking here if we've got line of sight. We're just logging that. And then we need to actually check, if we've hit and return that so that the AI knows whether it sees something or not, right? So we're going to make a nice little if statement, right? If B hit socket is double equal to false, and it's frozen again, there we go. Or, then in brackets, those aren't brackets, then in brackets we're just going to go hit result dot actor dot is valid, and hit result dot actor is owned by this, and 3 brackets at the end. Then we can say our out scene location is equal to our socket location. Our out sight strength is equal to 1. And we're going to return true. We have, in fact, hit and found something. Now we're going to write another const bool function, right? Const bool b hit, right? And this is going to equal get world line trace single by object type. Why can I not type single by object type? And then we're going to input again hit result first, then observer location, and then get actor location. And then after that, in this little space here, we can just copy paste all of this entire little chunk of code that we wrote earlier. We can just Control C and Control V that right there. And then we'll put a little semicolon at the end of that. Now we're once again going to just increase the number of line of sight checks performed, plus plus semicolon, and then we're going to go in again another if statement. If B hit is equal false, or again, I'm going to close that, or hit result dot actor dot is valid, and hit result dot actor is owned by this, 3 brackets at the end, and then we just want out scene location is equal to get actor location, out sight strength strength is equal to 1, and we're going to return true again. Now, if none of those have passed and both of those fail, we just want to say outside strength is equal to 0 and return false. There is one last thing left to do before we can wrap this code up, jump back into the editor and wrap this tutorial up. You want to go to tutorial, or whatever your project name is, build.cs. You're going to open that up, and here where you see public dependency module names, we're going to just add a public dependency module name called AI module. Now that you've got that, you should be fine to compile, and I will see you in the editor. Alright, welcome back to the editor. We're here again. And now, if we go to our third-person character, open Blueprint Editor, open Full Blueprint Editor, you'll see over here in the Details panel, if you can't see this, if you've selected something here, you can just go up here and hit Class Defaults. You'll see under Variables, we have detection socket bone name. If you want to see all the available bones, you can go to Mesh, double-click on Skeletal Mesh, and select Skeleton, and you'll see here the entire hierarchy of bones. I'm going to use Neck01 because it's a good place for good balance. It's like a location that I find has a good balance between, you know, yeah, I can see you, but it's also not too high, so they can't see you over walls or anything. So in third-person character, again, we'll go back to class defaults, and then in here, this is case sensitive, so just type neck_01, enter, and now you can press compile, get out of that, and now if you press play, walk up to your AI, '4, you'll see we've moved this detection point up. And this works for all points, right? So if we escape out of that, and I don't know, maybe we want the point to be on hand_r. Right, hand underscore, I cannot type today, hand_r. So now, if we play, you'll see the detection point sticks to hand_r. So yeah, that's about it. It's deceptively simple, but also kind of, yeah. The documentation just isn't there, and there aren't many resources, so I figured I'd make this tutorial. So yeah, there we are. This, of course, also will work on children, so if you do want to make children, I don't know, we'll jump into, not there, third-person CPP blueprints here, and we'll just make, we'll make another blueprint class. We'll make this, we'll build this off of tutorial character. Select, right, we'll just call this other character. Right, that's very beautiful right there. Actually, I don't know what I've built this off of, because this is not what I meant, what I wanted. Alright, let's go again. Tutorial character. Sure. No, that's the wrong one. I think it's the second one. Not a level. Oh, I'm just messing everything up now, aren't I? There we go. So now, a new character, right? I'll just set the mesh to, again, this fellow lad here, this fellow kid. And we'll go 30% NBP. And you'll see in class defaults we again have this, so we'll set his to neck_01, compile, and now I can drag new blueprint out as well. And you'll see that the AI, that AI, will now detect both of these characters with their respective different detection points. Alright, with that said, thank you very much for watching. I hope this helped you out, and maybe see you next time. Take care.